Hi, I'm Lawrence and welcome again to the Time Traveler's Guide to Mathematics. And today we're going to look at a very famous and influential mathematician called Fibonacci. Actually, his friends called him Leonardo da Pisa, as opposed to Leonardo da Vinci, who was of course another famous mathematician as well as an artist. Fibonacci lived towards the end of the 13th century in Italy, and in his day he was actually more famous for introducing the system of counting 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 that he borrowed from the Hindu and Arabic number systems. So even if he hadn't invented the Fibonacci sequence or discovered it, he would still go down in the history books of mathematics. The pattern that Fibonacci discovered we can see all around us in nature. And in today's video we're going to look at some things I've noticed in my own garden, from the neighbour's rabbit running around, from the eggs that my neighbours have given to me, to the oak tree in my garden, and to a problem that I solved with some balls of wool. So let's have a look at that. And here you can see a picture of my neighbour's rabbit running across my garden after digging up some holes. A nuisance to me, but an inspiration to Fibonacci. So one of the first problems that Fibonacci was asked to solve with his amazing magical mathematical powers was to do with breeding rabbits. Somebody wanted to know how many pairs of rabbits would there be after a hypothetical period of weeks, months, or even years. I say hypothetical because in reality rabbits of course don't breed like this. But let's pretend with these balls of wool that we have the original mummy and daddy rabbit. Well, they gave birth to a boy and girl pair of rabbits. So we had one pair, one pair, one. Now that second pair of rabbits give birth to their own boy and girl. Meanwhile, mummy and daddy, boy and girl, have grandchildren. They keep breeding. So now we have two pairs. 1 plus 1 makes 2. Now those rabbits gave birth to their own boy and girl. Remember, mummy and daddy rabbits keep breeding. But this pair gave birth to their own boy and girl. So now we have 3 pairs. 1 plus 1 makes 2 pairs. 1 plus 2 makes 3 pairs. They keep breeding. And now we have in the bottom row 5 pairs. 1 plus 1 pair makes 2 pairs. 2 plus 1 makes 3 pairs. 2 plus 3 makes 5 pairs. So Fibonacci had noticed in this sequence that the previous two consecutive pairs added up to a new total. So apart from the amazing discovery of the Fibonacci sequence, 1, 1, 2, 3, 5, 8, 13, etc., by adding the 2 previous consecutive numbers, Fibonacci then took this to the next level, which was a geometric level. And this gave rise to a very interesting observation about nature around us and even space. Let's look at this diagram. So here we can see a unitary square 1 by 1. That's joined by another unitary square 1 by 1. One pair of rabbits give birth to another pair of rabbits. We then have 2 pairs of rabbits, 3 pairs of rabbits, 5 pairs of rabbits, 8 pairs of rabbits. So each square is formed by adding the 2 before. 1 and 1 makes 2. 1 plus 2 makes 3. 2 plus 3 makes 5. And 5 plus 3 makes 8. So the next square is going to be a very big square, which would be 13. We haven't got space to draw that. Now the genius of Fibonacci was, not only did he set out his sequence in an interesting way, but he found that he could draw a shape based on the arcs of these squares. So just push in another pin, and we're going to go roughly through the middle of each square. Through the 2, through the 3, through the 5, and you can see the shape we're getting. You may have seen this in a snail, shells, even the way that a cat lies when it's sleeping, a rose, what about a big scale spiral galaxy? That's the 13, literally on into infinity. This gets very big very, very quickly. You can try this yourself. It's an interesting exercise. And there we have, from the Fibonacci sequence, 1, 1, 2, 3, 5, 8, 13. Take it onto a geometric level and we have a wonderful spiral. So here we have an example of a cat in a typical sleeping position, and we can see that the Fibonacci spiral fits quite naturally around its shape. Fibonacci continued to notice how this amazing sequence turned up in nature, and if we draw out the sequence in squares, it forms an amazing spiral. Here's an example in my garden, which is a succulent flower, and it makes this beautiful spiral shape. Roses do the same thing as well. In fact, we can see this all around us. If you think about galaxies, spiral galaxies, they follow the same Fibonacci pattern. So here is the Fibonacci spiral that I plotted with a piece of wool and some pins drawn out more carefully. And we can see that this Fibonacci spiral actually approximates the shape of an egg. Quite remarkable, really. It's almost as if the egg was based around the Fibonacci spiral. And here are some eggs that my farmer neighbour gave me. Fibonacci then noticed that this very interesting sequence could be applied to other things in nature apart from breeding rabbits. Here we've got the branch of an oak tree in my garden. I notice from one branch it's 2 branches by subdividing. 1 plus 2 is 3. And there we have the next subdivision of 3. 3 plus 2 is 5. I can just make out 5 there. 1, 2, 3, 4, 5. So this simple sequence that Fibonacci noticed and wrote about for the first time in recorded history although it was probably known in ancient India, has become a kind of blueprint for the world of nature and the world of the planets and stars around us. Some people have even said it may be even the signature of the creator himself.